Hey everybody, Matt Yankovic here. Wanted to show you my weekend project, something that I kind of spent several hours over the weekend playing with, getting ready. Um, Basically, what I've noticed is, you see a lot of graphs and charts, a lot of tools that show you all kinds of things, but it's sometimes hard for people to actually understand that small design decisions matter. And so, decided to try and manage and interact with both Postgres and PMM using an arcade controller. This one right here. Happened to buy this off eBay. Started to build my own, but needed a couple parts that didn't make it in time for this weekend. And I want to use this at a few upcoming shows that we're going to go to, like the OSS Summit and All Things Open, where we can try and show people how little things can interact with Postgres and cause disruptions. Also want to do this with MySQL and Mongo as well. But the idea here is each of these buttons on this control pad does something else with Postgres. So right now, this is running. And so you can actually see the workload behind here. And, you can see the different things that are happening. You can see that there is right now about 1,000 queries per second running. And you can see that the database connections, there's about 30. But before we get into that, I'm going to go ahead and I'm going to shut down our benchmark. I'm going to turn all the workload off. And I'm going to start over from scratch and show you what I did. So first of all, let me go ahead and show you some of the code that is behind this. And so you can see just over to my side here, you'll be able to check out this guy. Let me go ahead and I can make this a little bigger even. Okay. So from a code perspective, this is all written in Python. And so it should be available on my GitHub repository. There's two components to it. The first one is this, I call it DB board grabber, but it uses evdev, which interacts with USB devices and devices on machines. And basically what we've got here is this guy here, which is checking for events that happen. And each event, every button on this particular controller will do a different event, basically. And so here, we're just reading those events as they come in and looking for when the event has been triggered. So the button has been clicked or some other interaction has happened. And so as we do that, you can see different things happen. So here, this black toggle here is going to set this to either Postgres or MySQL, depending on what sort of workload I want to run. And so it will then stop the MySQL and it will start the Postgres version if we want. And you can see here some of the other buttons. So this particular black button, number 1, is running a vacuum. So it will actually run a full vacuum. So it's designed to be kind of abrasive and, stop things. So we want to see what that will look like. There's several other buttons that haven't been coded yet, you can see. But idea, refresh materialize view. We've got, the ability to create or drop indexes, specifically using the buttons. So these two green buttons right here do that as well. This guy here actually creates a brand new table, makes a copy of an existing table. So kind of tries to do some, a little bit heavier workload. Then here we've got the bulk of these, which are these switches in these toggles here. And so these are basically knobs. And with these knobs, what we're doing is going to be changing the workload. So each knob here has a different workload associated with it. The first one is general workload. So this is going to be a few inserts, but mainly selects reading data from our database. Second one's going to be reporting workloads, so doing aggregates, doing reports, some worse than others. Third one's going to be a very heavy insert, update, delete workload. And the fifth one is going to be long-running transactions. As we turn these knobs, it will actually spin off a new process to do that activity. So we can start this off as, one process doing this, or one thread doing this, one user, or we can spin it up to hundreds if we want to, just by turning the knob and spinning it. So we can simulate how much the workload will change based on what we've set on these particular knobs. Now, there's a whole debate between using threads versus using processes. I decided to use processes. I did try with threads. 6 one way, half a dozen the other. There's some benefits to using threads over processes and processes over threads. But basically, you'll probably get better performance if you're I/O bound through threads. And if you're CPU bound, typically the processes work a little better. So it's just one way or the other. So, might be interested to try both sides. But again, as you look through the code here, you could see, for instance, here's the multiprocessor. It spins off this thing called single user action v2 and passes it its parameters, and that is a separate thing. Then there's also the ancillary, hey, when I drop it, how do I get rid of it? And so those all call this PG Yonk library, which contains all of the code to interact with Postgres. So, the vacuum's in here, the add drop index is in here, all the different queries are in here. There's all these different functions for each type of query that I want to run. And then I aggregate all of these into these functions here, so insert, update, delete. So what this will do is this will run 10 insert statements. It'll run 5 updates, 6 deletes, and then it will randomly select inserts, updates, deletes to run as well. And so it gets this broad mix. And so again, I could make changes to how this is done, but the idea is it spins off one more worker that is basically doing this workload for every time you turn the knob, which is kind of cool. Now, as we do those interactions, it also annotates within PMM. So what you'll see, and I'll go ahead and I'll just jump over to PMM right now, is as the workload changes, you'll actually see these lines. You see the lines that are here right now. Those lines dictate changes in workload. So you'll be able to check out the annotation if you're interested, and you'll be able to see what those activities are doing. So right now, this is running, but to give you kind of a idea on what this looks like and how this works, I'm going to go ahead and I'll share my terminal with you really quick. Go ahead and share the terminal. So you can see here's terminal. I'm in this directory that has my DB board grabber, which is the program that's running to collect the interactions. So I'm going to go ahead and run that. I'll share my controller, and you can see that as I do activities, I'm actually just writing out to the screen right now, just so we can kind of play. So I just flip that toggle switch, the black one here, and that one is going to set it to MySQL, which isn't coded yet, so it's not going to do anything, but I'm going to flip it, and now we're back to the PG. So it's running the Postgres, and it starts off by loading data that's going to use when it processes, so it doesn't have to reload this on every thread. Things like loading all of the actors into memory, all of the movie titles into memory, things like that. And so as we go through each of these buttons, they do something slightly different. So I mentioned this one here is refreshing materialized views. So you can see that as I clicked on that, it wrote out, hey, I'm refreshing materialized views. And we should see that as an annotation show up as well in PMM. So if I come back to PMM real quick and I show you that, you can see that there's this blue line way at the very, very end here, and it should say, if I click on it, oh, it says running vacuum, but I didn't, so I just missed the annotation. So we found a bug already. But the idea is we have gone ahead and coded that up, so now the button actually does something that shows the annotation. It moves on. Now, Some of the buttons have nothing coded to them yet. So like this one, black button, I just, those have nothing. So it doesn't do anything. Doesn't annotate, doesn't do anything. So I need to pick functions to do that. I could do like a backup. I could do, different activities. So as we go through, what we want to do is we want to start running some of the workload that we've got. So what I'm going to do here is I'm going to start with this, which is the general workload. And so if we watch our screen, we can see that we have turned that up 1. And so we have this active list that has the PID of what's running. And then we go to 2, and then we go to 3, and then we go to 4, 5, 6. So we have now added 6 worker threads that are running that particular workload for us. So we should be able to see that start to show up on our graphs. And so if we go back and we can look at history of this, because I've been running this all weekend as I've been playing and trying to figure this out, we'll see that workload start to, rise in PMM. We'll start to see some of those queries show up on a regular basis. And so it's going to be a fairly decent workload. The data set right now is only about 10 to 12 gigs, so it's not huge. It's a very small data set, all things considered. The box that this is running on has 64 gigs of memory, so everything's going to fit into memory right now. Now, ideally, what I'd like to do is take each of these toggles and be able to run with different workload sizes. So, the first one would be that 10 gigs, let's say. Second one would take it to 20. The third one would take it to 100. The fourth one would take it to 200. So you could see like the changes in performance based on the size of the data that you're showing. But let's go ahead and let's take a look at PMM again, and let's see what we've got here. So I'm going to go ahead and remove the controller side of this. So you can see the graphs here, and you can see the lines start to show up. Now, what I've done is I've actually tagged all the annotations with either workload changes or schema changes or maintenance type activities. So we can remove just the schema. So schema would be vacuum, rebuild materialized views, add drop indexes, make a copy of a table, things like that. And so workload changes would be things like we're going to take general workload from 1 user to 10. And so each one of these lines represents one of those activities. So you can see that the database queries per second here, this is where we actually stopped our workload here earlier. You could see here's where we did that activity that I mentioned, click the button to rebuild the materialized views. It's misnamed. But here's the workload. So you can kind of see on that annotation, it might be a little too small. So let's go ahead and let's go to here. So you can see here that it is each one of those lines. So every time I turn the knob, it increases that workload 1. So at this point, that's going to be a line per increase, which if you're going to do thousands of them would kind of stink. But you look here, you could see general workload increase, G, R, IU, LT. So the idea is G is general workload, R is reporting workload, IU is insert update workload, and LT is long running transactions. So you could definitely see that these kicked off and you saw the workload increase. Now you'll notice that these, this increase actually started before these. That is because these annotations are real time, whereas all of the data points that are represented within Grafana here, PMM, are actually buckets that are bucketed in 1 minute. So if these happen in the middle of, while it's bucketing up its data, it's going to show before, or it's going to show after the workload has ramped. So there's some time offset there. So, plus or minus 1 minute basically is what you're going to be looking at here. So you can associate this increase in workload with this increase in database queries per second. It's within kind of one iteration either way of those. So that's why we saw the increase. Now, you can see that we're running, those 6 threads. We've got 635 queries per second right now, so we're at the peak of what we have been running at. You can see that, right here's the current. You can see that we're at that peak again. Now, if we scroll down here, we can see that database response time is pretty uniform. We're not getting a whole bunch of outliers yet, at least more recently. Early on, when we were running some of that workload to load the data, then we got some of those outliers. We can also see that from a CPU perspective, we're actually pretty close to, maxing out. We're at 75%. So we could increase our workload yet again if we wanted. So let's go ahead and let's take up these a couple notches for the general workload. So we kicked it up to an 8. Let's see if we get any bump in those particular, and you can see right here this purple line that's going to represent that increase in workload. So again, purple line happened, but this graph portion didn't fill in yet because it's aggregated buckets of data. So while we're doing that, we can go ahead and we can look at what kind of queries are running here. You can see that this update normalize movies normalize meta upvote. So setting an upvote. So this is where simulating kind of like, hey, I like this movie, I don't like this movie, and updating the movie. But also this title. You can see from a total time perspective, this selecting a movie based on the title is taking the most time. Now, if we wanted to take a look at that, let's go ahead and let's look at what that looks like in real, just for that particular query. You can see here's all of the changes to workload we had again. But let's go ahead and we'll remove those annotations for now. You can see that outside of this one, which is 153 milliseconds, most of the other ones were in the 100 millisecond range. So there were quite a few that were running in that 100 to 150 millisecond range. And you could see the number per second is consistently, this is running about 35 times a second, give or take. So, we've got some pretty decent stuff here. Now, if we wanted to go into the query analytics portion of this, we could as well. So let me go ahead and refresh this dashboard. This dashboard is QAN, so the query analytics that's built into PMM. And you can see here that we've got several of the different queries that are running. This one is the one that we're most interested in, which is this one that I was pointing out. So you can see that where it's spending most of its time. And we can also see that we don't have an index on the title. Now, I remember I said that these buttons, this one in particular, is the add drop index for the title. So what we're going to do here is go back to the PMM main dashboard that we've got. You can see that we're now up to about 700 queries per second. You can see that now we're also at 85% CPU utilization. So obviously we missed an index. It is a single index. It's not taking a ton of time. I mean, 100 milliseconds, not ideal. But for a lot of people, they're not going to think about query tuning or touching something unless it's over, a second or two in a lot of cases. So let's go ahead and let's click the Add Index button. So I've done that. And so if we want to take a look over at the shell, the output here, you can see that we have gone ahead and it's created the index on title. So we're good there. Now back to PMM, we should be able to see, if we refresh, you'll see the line for the change. So right here, this blue line, you see the blue line? That is the annotation that is we have added the index. And so you can see it says added or dropped the title index. So now we've used the controller to add the index to this. And also, we had to increase the workload a couple times. Just the one sort of workload with general. Again, we could do reporting. We can do the insert, update, delete workload, and we can do long transactions. So you can already see, though, the first kind of report coming in for this has the queries per second jumping from 694 to 2140 almost. So that's a significant increase, right? That is a massive increase. That's a 4x almost, between 3 and 4x increase in the number of queries. And the reason that this is important, and this is one of the things that a lot of people don't realize, especially when they've got code that is relying on multiple queries in a row. One query that is potentially just a little slow, maybe it's that 100 millisecond, maybe it's 50 millisecond, but it could be 10. It slows everything down below it as well. So the actual transactional throughput that you would get is much higher if you fix that natural bottleneck. But the problem is people ignore that natural bottleneck because it doesn't seem like a lot. But imagine you have 100 queries and each of the queries takes 5 milliseconds, but 2 of them take 200 milliseconds. That slows down all of the processing. It slows down everything behind that one thing. So you have basically what is an effective bottleneck with your functions, with your application. So really important to try and clear those out. I mean, in this case, what we saw, and the reason that I wanted to use this sort of visual is, hey, this one thing, this one small change, quadrupled, the throughput of the system because we could process data so much faster. Now, will you notice that in real time? How will your users interact? There's a lot of iterations or a lot of things you can go through there. But the idea here is there are small things that do matter greatly that could impact your performance. And so what we want to do is we want to visualize those, and PMM helps us visualize those. And obviously this type of a setup, when you're talking to someone real time, it's easier to let them click a button and see what those changes are. It's a more tactile response. And it's also kind of cool and geeky, and sometimes I just like to learn new things. And I hadn't done multi-threaded Python or interacted with a controller in Python before, so why not? Why not, right? So anyway, so back to our awesome PMM dashboard and the workload that is running. You can see now, things are still moving ahead. Let me go ahead. Where did I have lost my mouse, everyone. My mouse decided to flake out on me. It actually died. So wonderful. So okay. So we're going to roll with the punches here. So you can see here, not only did our queries per second increase, right? We see that now at 2,700. We can see that the CPU utilization for this dropped from what was peaking in the 80s all the way down to a 5%. So we went from a pegged out box to a box that isn't pegged at all. And you can look at the query distribution here, and you can see that now most of the queries are pretty good. Like, so this heat chart here, you can see that they're all in this kind of 0.1 milliseconds to 0.1 milliseconds. So they're running really fast and speedy right now, which is cool. And that's exactly what we want it to be. Now, again, there's not much I/O on this because this is all totally loaded in. I'm going to go ahead and I'm going to remove the the controller image from now. But the other thing that we'll notice is if we go back and we look at that title, right? So we wanted to look at that. Let's go to just look at that particular query and look at this. So check this out. So we were running at 100 milliseconds, 116 milliseconds, 150. Now we're down to microsecond. I mean, we're down, right? So look at this, 28. Yeah. So we're sub millisecond. I mean, that's a massive, significant decrease. You can look at the query response time here; it just drops off the face of the earth, just because we added that index, obviously. And so, obviously, indexes, everybody knows, are super important. Not a lot of people realize, though, even the small queries, the ones that seemingly are fast, 10, 20, 100 milliseconds, can make this significant of a difference. And so it's kind of interesting to see that. So the other thing that we want to do here is we want to go ahead and we want to up, some of the workload again. So we've only played with the one workload. So here's where we're going to take the workload. We're going to increase our reporting workload. So we've set our reporting workload to 3. Okay. And now we're going to take and throw some insert, update, delete workload. We're going to take that to 2, which will throw some inserts, some updates, deletes out there as well. So we've got a few different activities that are going on now. So we should be able to take a look at that. And let me go ahead and where we should see the Grafana. Yep. So you see these lines down here. You can see now that we've got 8 general workload. We've got 3 reporting workload and 2 insert update. So I'm going to go ahead and move the general up to 10 just so we can get a bit more. So now we've introduced some different workload to the system. We know that we were only at like a 5% CPU utilization before, so it wasn't huge. We had a lot of room to improve. We could throw some additional workload on it. We're going to add some more workers now. And so let's see what happens with this level of workload, because now we've added not just this kind of general, let's select a movie, let's see what the ratings are, let's see who's starred in that particular movie. Now we're going to do some things like, how many movies were there per year? How many movies did this actor appear on that were directed by this person? Those types of queries that are a bit more difficult, a bit more reporting-like. So we'll see what those do to the system. And then also, we're going to be inserting comments and updating a lot more on movie ratings and things like that as we go forward with that insert, update, delete. So you can already see that the workload has jumped from that 2,700 range. We're about 3,200 right now. So we are getting a bit more there. But you can see here that the CPU jumped pretty significantly. So we're at 65%. So when we just had that general workload, it was so quick. We were doing simple queries, nothing major. It was very insignificant altogether. And now you can see a pretty significant jump. And so if we look at, where we're seeing most of that jump from, you're going to start to see some other queries start to creep in here. Let's go ahead and let's look at the average time. And let's see what we get here. So from an average time perspective, you can see now we've got this. Oh, look, I want to count the number of actors per year. I want to see how many movies they starred in and what was the average rating for those. So, that's a query that is potentially going to show you, hey, between these years, this actor was active and he did really bad movies at the beginning of these years and he did better movies as his career went on, that type of a thing. And you can see that this particular one is taking, 1.4 seconds. So it's a pretty significant thing. So this one has the opportunity to actually tune this a little bit more. I've got my buttons coded up. I do have one, which I don't know if it's going to work or not, but we can take a look. So, let's take a look at the second button. This one adds a index on year. So right now we are querying the years. So we're saying between year A and B, and we're trying to aggregate based on that year as well, which has no index. So let's go ahead and let's fire that up. And we're going to create the index on year, which didn't exist before. And let's see if we see any better results from that. Okay. So, again, in PMM, we should be able to see the blue line. There's the blue line for the added index, and it will say we added or dropped the index on year, so we are good there. And part of this is what I want to do with the controller while we're waiting for this to come out is I want to be able to do things like the blue and yellow button here. This is code version 1, this is code version 2. So simulate, somebody deploying a new version of the application. So maybe the blue code is doing all of this work directly in the Java or JSON object as opposed to a normalized table, whereas the yellow one does the normalized table. And then we could do things like this button here is going to use an ORM framework like SQL Alchemy. This one is just going to go directly using the Python driver, right? So we can, make changes, and we can evaluate what those changes are doing to the system and get that tactile feedback. Again, each one of these does, a slightly different thing, right? And so, this gives us the opportunity to play, to try different activities as we go. As I mentioned, we've got rebuilding materialized views. We've got, rebuilding or doing a vacuum. So there's quite a few different things we can put on here, but it will help iterate and show people that sometimes the smallest tiny activity or changes or design decisions matter. Like, one of the big things that we often see is people choose the wrong data types, and it has a dramatic impact at performance at scale. So, we could do a deployment with a primary key of a varchar versus primary key of an integer. And so what do those two look like with the exact same workload, the exact same setup, the exact same number of knobs turned? It could be something that's really interesting and fun to do. Fun because I'm a nerd and it comes to databases. So the idea here is, we start to see these increase. Now, remember how I added that year index. So we see here that I don't know if we got, we went from 3.4 to 3.3. These queries aren't running a ton, but let's go ahead and let's see if anything happened with that particular query with us. So here's where we deployed our code, our new index. So you can see here that it was running 1.23 seconds, and it dropped down to like 1.6 seconds. So it didn't really do that much. Right. And so, this is another query that we can continue to optimize, maybe play around with a little bit, make some changes to. So what I'm going to go ahead and do is come back here. So we're up to 3,400. And we are, let's take a look at our CPU. Our CPU, we can still increase the workload a little bit based on the CPU. So we still have some ways to go. So let's go ahead and we'll add another reporting and some more insert, update, delete. We're going to take that up to 5, and let's really crank up that general workload. And let's see if we can max out the box. So what I've done is I've gone ahead and I've just, turned the knobs a bit more. And so now we're up to, let's see, let me go ahead and refresh this, and we can look at the annotation, the easiest way to do that. So now we're up to 14 general purpose workers, 4 reporters, and 5 just doing insert, update, delete type workload on the same data set with no long transactions. So what this should do is hopefully this will start to saturate the system. Let's go ahead and let's see what we've got down here. The other thing that, because this is all a self-contained, the Python code that's running and the processes that are being spun off are also in the same box, they're going to compete for resources. Ideally, we would have this on a different box. We could deploy this to have the controller work with a box that then just works and calls like AWS APIs. So we could do the interaction for an RDS Postgres or something else if we wanted as well. But adding all that extra workload, it did impact the CPU. We're now into the 80s, but that was only a 5% difference. So, we're up to, we did add another 1,000 queries per second. That's a pretty significant increase. So we've still got room to grow, though. So, we can push this a little bit more. Now, let's do the dreaded vacuum. Okay, so watch me as I click the button, and never do this in production while you've got a heavy workload. I'm going to run the full vacuum button. Okay, so I have just clicked that full vacuum button. And so hopefully this will start to kick off here. And there it goes. The vacuum is now running, everyone. And so if we come back here, and if you don't know what a vacuum does, is it's going to clean up all of your tables that have been being updated and deleted, and it's going to rebuild the indexes and optimize, array and analyze at the same time. It's going to refresh the data, so it's going to shrink it. So look at that. Immediately, we saw that we were peaking around 4,600 queries per second. The first reported iteration after we started the vacuum has dropped down to 3,000. I'm going to anticipate that that's going to continue to drop while that runs. The vacuum in this case takes about 2 minutes to complete. And we'll actually see that show up in the slow queries here that we've got as well. So that should be kind of interesting as we go. And if we look, we also saw a drop in CPU as things get blocked, because we're going to be blocking a lot of transactions from running potentially. So CPU, probably will go down a little bit. And we do see a bit of a spike in IO, not a terrible amount. Yeah, look at that. We're down to 153 queries per second right now. So again, you run like this maintenance command. Maybe you're not thinking about what you're doing. You're trying to do something, a little crazy, and that happens. So this is where a tool like PG, not PG backrest, PG repack, can come in handy, and it can help you, do some of that with a little bit less impact. And again, I could code up a button here for repack as well, so we could kind of play around with that. But again, little things matter. And as we go through, we can see, oh my God, when we come back and look, why did the query drop off? Because the vacuum's running, right? And so now vacuum has completed, so we're starting to see the rebound. One of the other things we could do is we could add in another annotation that says vacuum ended, so we can, kind of coordinate when that actually happened if we wanted. But you can see if we do this, see the vacuum full analyzed, normal meta, it took 1.71 minutes. So that's why it took so long, it basically just blocked everything. And, we'll be able to see those workload changes as we change things and, have different impacts. Now, one of the ones we didn't do is we didn't play with the long running transaction toggle here. So this one's the long running transaction toggle. What we can do is we can put in transactions, and it's going to randomly create some select statements and some updates and things that are going to purposely not commit for a certain amount of time. And so it'll open up, a table for update. It will select some data. It will do some things. It will wait a second, and then it will commit. So one of the things that I asked our support engineers, what's one of the biggest problems you see with our clients and their applications? And they said, oh my God, it's so many people do select for updates because they think they might need to update something and they don't realize how impactful that is. And so a lot of people introduce, even if they're micro locks for a few milliseconds, those create those bottlenecks, if you will, that are going to stall your system, right? Because, something that could take, less than a second to run, if you've got, 5 or 6 things that are stalled for, 200 milliseconds, those just pile up. And then all of a sudden it's a really, really slow system. And so, one of the things that you'll notice, a lot of our query workload with this particular, as we're running these different, the general and, even like the insert update and even the reporting, they typically will come to a plateau, and, it's pretty consistent. They're running a very similar number of queries per second. You might see, the odd response time spike based on, maybe you selected some movies that had, more data involved, and so it was a little bit more intensive. But largely, it's pretty flat. If we start to play with this knob, okay, because it does these longer transactions, and we do some randomness in how long those transactions are, you'll start to see spikes in the workload. And so you'll start to see these pretty massive spikes. Now, I can start that up now. So we'll start that up right now. But what I'm going to do is I'm going to go ahead and I'm going to show you. I'm going to get rid of the controller, not that. I'm going to show you from over the weekend. And so over the weekend, I ran this quite heavily. So you can see, the different things over the weekend. Here, let me go ahead and I'm going to run into this. Okay, and so one of the things you'll see is this massive up and down spikes. You see how these, just like come and they go. So at this time, I'm running these long running transactions. So I have two of them. And so, when you dig into these, what you end up finding is these peaks and these valleys. They're always caused, or mostly caused, not by things like auto vacuum or something like that, although that does happen. They're actually being caused by the increases and those lengths of those locks. So hey, you've got this long running transaction and it selects a movie no one else cares about. It's fast because it's locking it, no one's accessing it at the same time. If you choose one of those movies randomly that someone else has been, looking on or trying to vote on or trying to add a comment to that particular movie, then that's what locks it up. So you can see those spikes and that randomness, and you can see, that there's quite a bit of up and down on those. And, you see like the response time distributions, you can see some of those spikes as well, where some things just take really long and some things are really short. Now, largely, most of them are down here in this short time frame. But, those spikes are real and you do see them. And sometimes they, manifest in different ways. Anyways, so that was my weekend project. If you have some suggestions on what you would like to see on the database controller, the Yonk controller, go ahead and let me know. I would love to add some more workload. Like I said, there's a lot that I want to do with this to just kind of play around and be able to visualize some of these activities that we see in a regular basis that are causing people a lot of angst. And so if you go ahead and subscribe or like and put a comment on what you'd like to see and what we can do a little bit different. Next version of this will probably fill out this board. Then the one after that, I'm going to build a bigger board myself. I've got all the components. I want to do a bit more with the workload and the number of threads and a few other things. So thanks for watching, everybody.